Hi folks, this is Kwabena from OpenMV, and today I'm just going to be talking about how to use our RPC library on the desktop to transfer images from the OpenMV Cam to your computer. This should run on any operating system as we just use Python. So it should work with a Raspberry Pi or a desktop computer or Mac, Linux, and Windows. Anyway, for this demonstration, I'm going to be showing how to use it on Windows. So first, inside our GitHub repo, we have the RPC library, which literally is just one Python file, and there's a README. And you can see these all online. There's a great explanation for it. This comes with a few example scripts. So there's the image transfer as the controller device and image streaming as the controller device. I'm going to be talking about those two scripts today because that's what we've getting a lot of folks asking about, how to transfer JPEGs. And then also inside of your examples directory on your OpenMV Cam for OpenMV IDE, there's a bunch of RPC scripts that you use on the OpenMV Cam to connect to the computer. And so you have image transfer, JPEG streaming, RAW, and popular features. The popular feature scripts are meant to pair with each other versus the image transfer, JPEG, and streaming are meant to pair with these over here. And then the RAW as the controller and remote are for pairing two OpenMV cams to each other as explained in the example scripts. Anyway, so to get these things working, let's do image transfer JPEG as the remote device. So what we're going to do is we're going to grab that script, and we're going to copy and paste it inside the OpenMV Cam. We're going to delete main.py, and we're going to rename this script to main.py. After you do that, make sure to eject the disk from your OpenMV Cam because the computer will cache writes and will not do them immediately unless you eject. This is because the internal flash drive in OpenMV Cam is so tiny that the operating system uses the same drivers that it would use for a floppy disk, and it just caches all the writes locally and only does them at the very end when you hit eject. So we're going to do that. Once the camera is ejected, we're going to physically unplug the camera and then plug it back in order to restart it. Once that happens, the flash drive is going to pop open again. Cool. And now we see we have a main.py sitting on the flash drive. Now let's just check to make sure that main.py actually got the script on board. And we can see image transfer as the remote device has been written successfully. It's not corrupted. Great. Okay, so the OpenMV Cam will now be running that script. Next, just take a terminal to the RPC directory, and we're just going to do Python RPC image transfer JPEG as the controller device. We're going to run that. It's going to ask you, hey, here are some serial ports. You're going to do COM7, boom, enter that, and here I am. It works. And so the OpenMV Cam is now taking pictures, JPEG compressing them, and it's sending them to the computer over the RPC library. I'm using RPC library calls. Now you'll notice the frame rate isn't particularly spectacular. That's because each individual frame that we're getting here is being called using a callback handshaking mechanism that's designed to handle either device being out of sync with each other. This allows for, like, your computer, for example, could go off and do something for many seconds and then come back to requesting from the camera and you'll have no problem. But or the camera could go off and do something and the computer would handle it. But it's not going to give you the highest bandwidth. That is what the image streaming example is for. So let's run that next. All right. So image streaming, we're going to grab that script, copy it, paste it over here, delete main.py. All right. Rename that main.py. And then we are going to eject the drive as mentioned before. Make sure the write happens. And then we will remove the OpenMV Cam, plug it back in. Okay, now let's just check to make sure that got written appropriately. And this is image transfer as the remote device. Okay, so you see this, that's an interesting issue happened there. I don't think this actually wrote it correctly, unless I grabbed the wrong script, so let's try it again. So let's rename that, put that over here, delete that. Name this main.py. Okay. This should say image streaming. No, huh? Am I grabbing the wrong script? Oh no, this is the stream generator. It's just the script has a poorly named. Okay. Yeah, no, this script generates JPEGs in a JPEG streamer callback. So, okay, that's just what was confusing me. All right, and let's make sure that's written. Cool. Okay, great. Okay, let's eject that. Okay, unplug, replug the camera. Let's just verify. Same script, cool. So the stream generator is there, and so this is going to generate data in a stream. Awesome. Next, we're just going to go to Python, and we're going to do JPEG streaming. And it is RPC image transfer JPEG streaming as the controller device. Click that, COM7. Boom. And now we're fully JPEG streaming. And so you'll see the frame rate went up to about 14 FPS. And so it can go faster. It just depends on what the camera's up to right now. Since we're in a dark room, the camera's not really exposing for a long time. See, if I put it to the roof and the frame rate speeds up, then it goes to 30 FPS. Cool. All right. And that's about it. And if you want to make the resolution higher, I believe the script itself has that information on it. So if I go to JPEG streaming, go to edit that, we can make that, you know, QVGA, right? COM7. Cool. Now we're doing QVGA. And did you see that kind of glitchy error there? So what's happening there is that's like JPEG byte corruption, effectively. What's going on with the RPC library is that it does nice RPC protected handshake and callbacks that prevent any data being lost. But the second you grab the window and move it around, what happens is the thread that is reading that data is blocked during the redraw of the window. Typically, if you wanted to do like a more professional application, you would have two separate threads, one that manages the GUI and manages the movement of the GUI, and a separate thread that manages the I/O. For this simple example, I didn't do that, and so when you literally move the frame around, this actually causes the thread that is grabbing data to completely be blocked. But the RPC library is designed to handle that. So you see that little glitch that happened there? What happened is the camera figured out that I wasn't listening anymore, the computer thread, and the whole stream callback system crashed. Well, it didn't crash, but the RPC library basically took that down and broke down the stream. And then the second I let go of the window, the computer then reestablished an RPC stream and then started streaming data back to the computer. And so it all happens in the background, and you don't think much is going on, but there's actually a huge number of transactions that just happened back and forth in order to make sure that I can just grab this window and then let go, and it keeps going. That does not happen automatically. But we've done that for you for the OpenMV Cam. Anyway, and that's about it. Let's see. Let's go faster if we point it to some light. It's a bit cloudy out in San Francisco. Yeah, cool. And that's about it. And we can also go, I think you can do VGA, but remember this is the H7, not the H7 Plus, so it's going to be a little bit limited on the RAM there. Yeah, great. Yeah, we can go VGA too. And just the Pygame frame counter is kind of bad. It does average of 10 frames when it's figuring out the time, so you should just ignore what that's saying. Anyway, that's it. Don't resize the Pygame window. It doesn't handle that. And that's about all. All right. Thank you for watching. Bye-bye.